Hi friends, welcome back to my channel. Still on Power Machines and 5, today we are doing combustion of fuel by volume. My name is Tsepo. Please subscribe to my channel to make sure you keep on receiving videos like this. Click that notification button so that you will be notified every time I post a new video. So, combustion of fuel by volume. Hopefully by now you have already seen the lesson or watched the video on combustion of fuel by mass. And then from fuel by mass, we know that if we are looking for the amount of oxygen that is required to completely burn, for example, hydrogen, we will say, and then the product will always be oxygen for nitrogen. The first thing that we have to do is to balance the equation. And then we will get something like this. And then after balancing the equation, we will have to substitute the atomic masses of each and every molecule in our formula. So we will have to do this. We know the atomic mass for hydrogen is 1 times these 2 plus for oxygen is 16 times 2, it's equals to 2, 1 times 2 plus 16, where we will get 4, and then we simplify there, we get 32, and then we get 36, yeah, 36, it's 32 here, and then 36. And then after, we will divide throughout by 4. 1. And then here we will get 8. And then we have 9. And this will tell us that for every 1 kg of hydrogen, we need 8 kg of oxygen to completely burn the hydrogen and form 9 kg of water. So this is like a reminder from our previous lesson, which was combustion of fuel by mass. But now we are doing combustion of fuel by volume. So same molecule, hydrogen. We want the amount of oxygen to completely burn the hydrogen by volume. So the one that we just did was by mass. Now we are doing, we want the amount of oxygen required by volume. So first of all, with both the volume and the mass, the first step that you must do is to balance your equation. We have already did that. Our equation is balanced. Now, with volume, we no longer use the atomic masses, but we will now use the number of molecules in the system. So let's do this. We know when there is nothing in front, it's the same as saying there is 1. So this is what we will be dealing with now. So from this stage, because we are looking for the amount of oxygen required to completely burn 1 kg of hydrogen, we will divide throughout by 2. And then it will be like this. And then we will have, here we will have 1. And then here we will have 0.5. So it's 1H2, 0.5 oxygen. It will be equals to 1H2O. And then this tells us that for 1 cubic meters, it's no longer kg, we are dealing with volume, plus 0.5 cubic meters, it's equals to 1 cubic meters. And this tells us that for every 1 cubic meter, or for every 1 cubic meters of hydrogen, we will need 0.5 cubic meters of oxygen to completely burn the hydrogen and form a product and form 1 cubic meters of water. So this is how we calculate for the amount of oxygen required by volume. And then another thing, another difference between the volume and the mass is that we know that we said from our previous lesson, which was combustion of fuel by mass, we said that air by composition consists of 23% oxygen and then 77% nitrogen. This was by mass. By mass. Now in volume, air will consist of 21% oxygen and then 71% nitrogen. This is by volume. By volume. So these are the major differences between the combustion of fuel by mass. How do you calculate the way we are calculating for the amount of oxygen needed in when they said by mass and then when they said by volume. And then these two, by composition, air consists of 23 and 77% nitrogen is by volume, by mass, and then this is by volume. So because now we are in combustion of fuel by volume, this is the information that we are going to use and this is how we are going to calculate for the amount of oxygen required. Even for hydrocarbon gases, you will, let's take for CH4, which is methane. We know there is a general formula to balance this equation. And then after balancing the equation, we are dealing with the number of molecules, no longer the atomic masses. So with that being said, I have a question paper to help us understand more about the combustion of fuel by volume. And then my question paper reads as follows. The composition of a gaseous fuel has the following structural analysis according to volume. Hydrogen is equals to 37%, CH4 is equals to 29%, carbon monoxide is equals to 19%, sorry, it's 18%, and then carbon dioxide is 1%, nitrogen is 15%. Air composition consists of 21% oxygen and 79% nitrogen. Then the questions. They say calculate the following. Number 1, the volume of air required to completely burn 1 cubic meters of the fuel. So they gave us this data. They gave us the analysis, the structural analysis by volume, and then they told us the composition by air, that 21% of the air will be oxygen and 79% of it will be nitrogen. And then they gave us the total amount of volume that we are dealing with. So to simplify things, we are solving these questions using a table just to simplify things. And then the first thing we must do, since we know that we are dealing with 1 cubic meters, we know we will say 39% of it, of the fuel, which is hydrogen, here will be 0.37 cubic meters, and then 0.29 cubic meters, 0.18 cubic meters, 0.01, 0.15 cubic meters, and then we must get our answer as 1 cubic meters, since that is the volume that we are given. And then we go to the next column. The next column is the formulas. The formulas. First, for hydrogen. Hydrogen, H2 plus oxygen will give us water, which is H2O. We know that this formula is not balanced, and then we must balance it. And then after, I said we are considering the number of molecules. So we write this formula as it is. We say it's 2. First we must divide by 2 throughout. 2, 2, 2, and then we get a formula that says H2 plus 0.5 oxygen, it's equals to H2O. And then we write this formula here. H2 plus 0.5 oxygen, it's equals to H2O. We are done with this formula, and then this is the oxygen required. So the oxygen that will be required by this hydrogen in this fuel, we will say 0.5, since we know that for 1 kg 0.5 cubic meters will be required to completely burn hydrogen. But now we are dealing with only 0.37, not 1 kg, so we must times by the actual mass, that the actual volume that we are dealing with in this case, and then get the amount of oxygen that will be needed by volume, and I got that my answer is 0.185 cubic meters. And then, okay, let me write the cubic meters. And then we move to the next one, methane, which is CH4. And then we know that the general equation to balance this formula, we will say it's plus xy divided by 4, it's equals to x, if I'm not mistaken, CO2 plus y divided by 2 H2O. Yeah, and then we know that our x is 1, and then our y is going to be 4, and then we substitute these values. CH4 plus, it's going to be 1 plus 4 divided by 4. Oxygen is equals to 1 plus 4 divided by 2 H2O. And then we simplify, we will get 2xH4 plus, this will give us 2 oxygen, that's equals to CO2, this will give us 2 H2O. And then we take this formula to the table, since it is for only 1 cubic meters of the methane. And then we say CH4 plus 2 oxygen, it's equals to carbon dioxide plus 2H2O, H2O. And then we are done with this one. We move to the amount of oxygen that that is needed for methane, and then we can see that the number before the oxygen is 2, so we'll say 2 times the actual amount of the methane in the system, which is 0.29, and then we get that our answer is, I got that it is 0.58. 0.58, and then it's cubic meters. And then we move to the next one, which is carbon monoxide. So carbon monoxide, we do the same things, plus oxygen will give us carbon dioxide. And then we know that this equation is not balanced, and then we will say 2, 2. And then now it is balanced. We will be dealing with the amount of molecules, then we divide through by 2. So we will have carbon monoxide plus half oxygen. It's equals to carbon dioxide. And then we write this formula into our table, which will be carbon monoxide plus half an oxygen will give us carbon dioxide. And then we say this number, which is 0.5 cubic meters, times the actual amount, the actual volume of carbon monoxide in the system, in this fuel, which is 0.18. It equals to 0.09. And then for carbon dioxide, we know that carbon dioxide doesn't react. Which was this nitrogen also doesn't react. Therefore, they will not require any oxygen because they do not react. And then from here, we calculate the amount of oxygen needed by volume, which is the sum of these three. And then I got that my answer is 0.855 cubic meters. And then remember the question, in the question we are asked to calculate the total amount of air required in the system. So we will say this amount of oxygen times 100 divided by 21, hence the information given to us. And then I got that the amount of air required in the system is 4.071 cubic meters. So that is the answer for our first question. So then let's look at our next question. They said we must calculate the total percentage analysis by volume of all the products of combustion. So the percentage analysis by volume of the products, we will have our first product that we know of is going to be nitrogen. So nitrogen, we can tell from this amount of air, we know that 79% of it is going to be nitrogen. Or we can just simplify things and then subtract the amount of oxygen that we know it is in the system. It is in the amount of air. Then we will be left with the amount of nitrogen from this stage. Then the amount of nitrogen will be this minus this, and then I got that my answer is going to be 3.216 cubic meters. And then in the analysis they also gave us nitrogen. So let's do our products here. These are our products. I say nitrogen number 1. There will be no nitrogen in hydrogen, no nitrogen in methane, no nitrogen in carbon monoxide, and then no nitrogen in carbon dioxide. But we know that there will be nitrogen because here we are given nitrogen. So it will be 0.15 plus the nitrogen that we found in the amount of air that was let into the system, plus 3.216, which is this nitrogen. And then we got that the total nitrogen that will be in this system it's going to be 3.6366 cubic meters. And then we are done with our nitration. Let's erase this. We go to our second product of combustion. Let's do for carbon dioxide. So from hydrogen there will be no carbon dioxide. From methane there will be carbon dioxide. And then this carbon dioxide, we see that it is 1 methane plus 2 oxygen is equals to 1 carbon dioxide. Then we will say 1 carbon dioxide times the amount of methane in the system, which is 0.29, and then it will give us 0.29. And then we go to this carbon monoxide. We can see that our product here is carbon dioxide, and then there is also 1 here. So we say 1 again times the amount of carbon monoxide in the system, which is 0.18, and then it will give us 0.18. And then we were given carbon dioxide. From our analysis we will come and add it here, which is 0.01. And then from here there is no carbon dioxide. And then we come and say the total amount of carbon dioxide that we will have in this system, it's the sum of these 3, and then the total will be 0.48 cubic meters. And then we come to water, H2O. From this we know that there will be H2O as a product, and then the number of molecules of H2O here, it's 1 times the amount of nitrogen in the system, which is 0.37, and then this will give us 0.37 cubic meters. And then we come to our second one, which is methane. We can see there will be water as a product for methane, and then we say 2, since we see that the molecule number of this is 2, and then 2 times the amount of methane in the system, which is 0.29, and then this will give us 0.58. And then we come to carbon monoxide. There is no water. We come to carbon dioxide, no water. We come to nitrogen, no water. And then the total amount of water in the system will be the sum of these 2, which will give us 0.95. Give us 0.95 cubic meters. And then we come and get the total amount, the total mass of products in the system, and then it will be the sum of these 3, which will be 3.364 plus 0.48 plus 0.95, and then the sum of this will give us 4.796. This is the total amount, is the total mass of the product that will be found in after combustion, and then this is cubic meters. And then to get the analysis that they said we must calculate for, we will say let's start for nitrogen. Let's do for nitrogen. For nitrogen, we will say the mass of nitrogen, which is 3.366 divided by the total amount, the total mass, the total volume, the total volume of the product of combustion times 100, which will give us 70.18%. And then we do, let me erase this. This is for nitrogen. We do also for, let's do also for carbon dioxide. You know that the total amount of carbon dioxide is 0.48 divided by the total volume of the product of combustion, which is 4.0796 times 100. And then I get that my percentage for this, for carbon dioxide, is 10.01%. And then we do for H2O. So for H2O, the amount of H2O in the product will be 0.95 divided by the total volume, which is 4.796 times 100. And then I get that my answer for this is going to be 19.81%. And then let's erase this. And then at the end, the total must be 100. Don't forget to write this. There are marks for writing this. So you must write everything in this table, because everything has a half mark. Do not leave anything. So this is basically how we go about answering combustion of fuel by volume questions. And that is basically the end of our lesson today. Hope this lesson will be of help to you. Don't forget to subscribe if you are new here. Share this video, comment and like it. So from me to you, my name is Tepo. I will see you on the next lesson. Ciao.